You look up into the night sky on a clear night, and as you gaze into the countless twinkles and flashes of light, what you're actually seeing is a moment in the past. The light we see today has traveled thousands of light years to finally blaze vibrantly into our eyes. Even our own sun's light that we see every day is 8 minutes old before we finally get to embrace it. We are all the byproduct of stars that died long ago, and that is to say, we are all the children of stars. The life of a star is long, starting from the collection of floating dust in the cosmos until there is enough gravity to condense matter and create fusion. At that point, a star's lifespan is directly dependent on the amount of mass it contains. This is a simple summary of how a star works, and the intention of my speech is to shed some light onto the parents of the universe. Today, I will explain to you in further detail how a star is born, how it lives, and how it ultimately dies in the most spectacular, magnificent fashion. Richard Brill of the Scientific American says that a star is born when the atoms of lighter elements are condensed under enough pressure that their nuclei begin fusion. All stars are the result of two opposing forces maintaining perfect equilibrium. The force of gravity, which is the constant attraction among anything with mass, and the outward push of energy through the process of fusion. While these two forces provide a constant and equal state of tug of war, the star remains happy and stable. Floating clouds of dust and gas are very common throughout the cosmos, which we call nebulae. They usually span several thousand light years across and contain enough mass to produce thousands of stars the size of our own sun. Most of the gas contained within nebulae are hydrogen and helium, which are the most abundant elements in the universe, and also the lightest and easiest to fuse. As the density in the cloud becomes greater, gravity begins to pull the molecules closer together. The temperature rises until nuclear fusion is sustainable within the core and it begins to spin. Any remaining dust around the star at this point heats up and glows brightly until radiation pressure blows away the dust, and like a newborn entering the world, a star is born. Now that we know the origins of a star, I'll explain what happens during its lifespan. Craig Frudenrich explains how a star's light depends on how big the star is and also what state it is in its life cycle. Light from a star is the byproduct of the fusion process within the star's core. As fusion releases energy, the matter begins to glow with high volumes of energy, which bounce and bump violently into other nearby atoms. On average, it takes one proton 1,000,000 years to finally breach the sun's surface. The bigger the star, the faster it burns through its fuel due to the increase in gravitational pressure, which in turn increases the rate of fusion. The star burns much brighter than our sun, but exponentially reduces its own lifespan. The biggest stars in the universe have already burned out because of this. Our star is an average-sized midlife star, which takes about 10 billion years to finally burn through its fuel. The smallest stars in the universe will burn for the longest time, and it's theorized they'll burn for almost 1 trillion years before they run out of fuel. Now that we know how a star is born and how it lives, now I will explain how stars finally die in the most spectacular and impressive way. Fraser Cain of the University of today states that once a star is unable to convert hydrogen into helium depending on its size, several things can happen. If the star is half the size of our sun or smaller, pressure from the electron density degeneracy will prevent the star from collapsing and turn it into a white dwarf. If the star is the size of our sun or bigger, layers of remaining hydrogen will continue to fuse and the star will begin to expand, causing a red giant. When the hydrogen is finally used up, the star can no longer sustain itself through energy being emitted and begins to rip itself apart in a phenomenon called a supernova. The eruption will be violent, bright, and anything caught within its path of devastation will be obliterated. In some cases, what's left after a star is detonated is a super dense core which continues to pull matter and energy, called a dark hole, black hole. In conclusion, I hope this information has at the very least intrigued your minds. The cosmos is a mysterious and dangerous place with things and events we cannot begin to imagine. And it would and eventually will be a much darker place to exist. The next time you look up at our sun, stop and give it a thank you. Because neither you nor I will be here today without stars. Thank you, and here's my audience.